Okay, welcome back to Math Questions with Engineering Row, where we go into some math questions. On this series in particular, we're doing questions that students tend to get wrong in their maths GCSEs. So we have the question, solve the equation x over 2 minus 2x plus 1 equals 1. And this is for 4 marks. And only 6.3% of students got 4 marks for this. So let's try and figure out how to do this and how to get our 4 marks. Well, to solve the equation, what we're really trying to find is x, right? So that's really what they're asking you. What is x? So we know the answer is going to look something like x is equal to something, yeah? So the aim is to get all the x terms on one side. But before that, I can see there's fractions. And whenever there's fractions, it's always easier to get rid of the fractions. But before that, we can see there's 2 different fractions with different denominators. So let's start by trying to make them, both of the fractions have the same denominator. So we have x over 2. Now, to make both fractions have the same denominator, I'm going to make them have the denominator of 2x plus 1. Okay, why? Because this is the easiest denominator to make both of them have the same of by timesing it by the other denominator. So let me go through it and it'll make more sense. So I'm going to times this first equation, x over 2, by x plus 1 over x plus 1, right? And this is not going to change the value. This is basically 1. Any fraction that has the same numerator denominator is equal to 1. So you're basically times it by 1. So you're not changing the value, but we're going to make the denominator 2x plus 1. And then the second fraction, which is 2 over x plus 1, we're going to times this by 2 over 2, which again is just 1. And then we're going to multiply the numerators in each instance. So this will turn into x plus 1 over 2x plus 1. And then we have 4 over 2x plus 1. And that is equal to 1. So now we have the same denominator. Because we have the same denominator, we can actually combine both fractions into one big one. And I'm just going to simplify it. So expand this and also expand this for the next step. So that'll be x squared plus x minus 4 all over 2x plus 2 is equal to 1. Now we have a fraction, so we still want to get rid of that fraction. How do we do that? We times both sides by the denominator, 2x plus 2. I'm just going to start on the other side. So if we times both sides by 2x plus 2, you'll get x squared plus x minus 4 is equal to 2x plus 2. Okay, so remember we're trying to solve for x. So the answer is going to look like x equals to something. So we want to get all the x's on one side. X squared minus x, so that's take away 2x on both sides, and then take away 2 from both sides, so that would be okay. So now we have something that should look very familiar. This is a quadratic equation, so we need to now factorize it to solve for x. So what 2 numbers will when added is equal to -1, and when multiplied would equal to -6. So that would be x minus 3 and x plus 2. That's equal to 0. So to make this equation true, x would have to be equal to 3, or x has to be equal to -2. And that is how you get your 4 marks. So this question, 3 marks, and only 4.3 of students got 4 marks for this. And it is expressed the recurring decimal 0.281 recurring as a fraction in its simplest form. So when you have a question like this with recurring decimal, it's simpler to allow x or any other letter represent this recurring decimal. So we're going to allow x to equal 0.281 recurring, or 0.2818181 ... Okay, so what we're going to do is we're going to multiply both sides by a number that would make the reoccurring portion of the decimal after the decimal point. So after this point, it's just the same repeated 818181. So we want to multiply this number by another number that will move this decimal point 1, 2, 3 times. So that is the same as multiplying this number by 1,000. So we're going to multiply both sides by 1,000. 1,000x is equal to 281.818181 recurring. Okay, so that's step 1. The next step is to find another multiple of x that we can subtract from this first term, 1,000x, that would make the answer a full number. Okay, so to do this, it's a little bit of problem solving and thinking ahead. So if I took away x, so 281.8181, take away, so 1,000x minus x, so that'll be 281.8181 minus 0.281. That would give me a recurring number. So let's just try that out. So if I took away x, which is equal to 0. Let's put the decimal points in the same place, shall we? Zero 0.28181. What we'll have is another recurring number. So it would be 281.6 363, and it will just be another recurring number. So we don't want that. We want the answer to not be a recurring number. So we're going to try another value. Instead of x, let's try 10x. Let's try 10x. And that is the method of these kind of questions. Try x, 10x. Generally it's multiples of 10s, but it could be 9x, 11x. You kind of have to think ahead. So if I try 10x, that would be the same as 2.818181 recurring. You can see the reoccurring part, where you minus it from each other, it would cancel out. So this would cancel this, and you're just left with simply 279, which is what we want. You want a whole number that's not reoccurring. And in terms of x's, that's just 990x. And we are almost finished. Remember, this is not the final answer, so let's solve for x, which is what the question is asking. So divide both sides by 990. And this is our final fraction, but it says in its simplest form. So looking at the numerator and denominator, can we divide this further? Now, a trick I learnt is if you can add the digits of a number and it's equal to a multiple of 9, then it could be divisible by 9. So looking at both the numerator and denominator, I know I could divide both of them by 9. So that would give me, at the bottom here, 110. And at the top, that would give me 31. Okay, can I divide that any further? I don't think so. And so that is our final answer for 3 marks. So for this, you have to show your working. That brings us to the end of the video. Thank you so much for following and watching till the end. Please remember to like, subscribe and share this to anyone else who you think might find this interesting. Thank you.